to town, from London to Taiwan. I've been all around the globe trying to protect your...
What is up, everyone? It's launch day. Yes, launch day. Oh yeah, it's gonna be a good one. What's going on, everyone? We're going to be watching the United Launch Alliance Atlas V today. It should be a great launch. Very excited about it. So, yeah, it's going to be a good one. We are currently waiting on ULA to go live on their end. As you can see, we still got about 5 minutes left until they are live, and we'll be joining their broadcast and watching them. So yeah, I'm checking their Twitter right now just to see if there's any updates on the account. Let's see. Yep, looks like all conditions are acceptable for launch today, so that is definitely good news. And they are going to be launching the 421 variant. Come on, turn down the music just a little bit. So, let's see, still got a little bit left until the webcast is live from ULA. But they are going to be launching a... Come on, turn this down just a little bit more. No, not silent. They're going to be launching a satellite that's going to be able to detect missile launches around the world for the United States Space Force. Going to be using the Atlas V 421, meaning that it is using a 4-meter bearing payload, 2 solid rocket motors, and 1 upper stage engine on the Centaur. And we're just going to wait for them to go live, and then we shall get to it. Gonna be an exciting time, though, I can tell you that. Launch days are always fun. Haven't had a launch day in a little bit. This is my first time streaming a launch. But it should be a good time. All right. Alright, so like I said, we're just waiting on them to go live. Oh, they are currently live, it looks like, just nothing's happening. So, once they're on and talking, we'll switch over to them. Oh, sorry about that. Alright, we are almost there, ready to go. Now there is going to be a little bit of a delay between what I'm seeing versus what the rocket's doing, and then what you guys are seeing. So if you're watching the actual ULA live stream, it's probably going to be ahead of what I'm actually seeing. So just gonna wait on them. Yeah, exciting. The rocket should be lifting off at 1:31 Eastern Time. So roughly here in about 20-ish minutes. And weather is currently at 90% go from launch. The last that was checked. So it looks like we're going to have a good liftoff time. Just waiting on that. Let me actually go check because it's a little weird. Well, they should be live. Let's see. Also, if you want to see, this is, if you are in the area of where the launch is occurring, this is going to be the projected flight path that it's going to take. As you can see, if you're in any of these areas in Florida and a little bit in Georgia, if you're in the Bahamas, you'll definitely be able to see it. So, yeah, if you're in this area in Florida, head outside, check it out. Still waiting on them right now. They are live, just waiting on some more to happen. Really need to go down there for a launch live. It's been a while since I have seen one. Last time I saw one was a space shuttle back in 2011. It has been a while. Alright, there we go. Alright, so I'm gonna pause the music. We're gonna get ready for them and watch the mighty Atlas V lift off. If you guys have any questions, want to talk about something, anything like that, send it in the chat. I'll answer it as best as I can. And we'll wait on them. Hopefully today will be a good liftoff. Yesterday they got pretty close. It was before the broadcast went live. They ended up scrubbing the launch. Turned out to be a sensor was giving a wrong temperature reading. It turns out everything was actually fine. Just the temperature sensor was reading wrong and incorrect, so they went ahead and scrubbed it. But beforehand, it was fine. Well, it was fine the whole time, but faulty sensors. Boom. Oh, it looks windy out there.
At Space Launch Complex 41, an Atlas V rocket is fueled and ready to launch the 5th Space-Based Infrared System satellite for the United States Space Force. Good afternoon and welcome to Cape Canaveral Space Force Station in Florida. I'm Dylan Rice, Systems Test Engineer, Launch Conductor, and the host of this afternoon's broadcast. Liftoff is set for 1:31 p.m. and we have a 40-minute launch window for today's launch attempt. A few seconds from now, the count will enter a planned 15-minute hold. We have 2 planned holds in our 7.5-hour launch count today. These holds give our team additional time to resolve any issues prior to entering terminal count. However, at this time, the team is not working any issues and we are proceeding towards an on-time liftoff. Early in today's show, we'll hear from Systems Engineer Tim Pika about getting today's mission ready for flight. Then stay tuned after liftoff to follow mission events leading to spacecraft separation and to learn more about the SBIRS GEO satellite from a recent conversation I had with Lockheed Martin's Melanie Young. And Lieutenant Bryce Leader and Lieutenant Adam Farrell will join me here in the ASOC to talk more about this mission and the important work done by the SBIRS constellation of satellites. In addition to watching our webcast, you can also follow live mission progress at ulalaunch.com. Jessica Williams, weather officer for Space Launch Delta 45, recently briefed the team. Here are the numbers. The probability of violating launch constraints is less than 10%. Ground winds are 17 to 22 knots out of the east, and the temperature is 80 degrees Fahrenheit. With that forecast, the weather is within launch commit criteria and looks favorable for our planned T0 of 1:31 p.m. Eastern Time.
That's good to hear.
Flying easterly heading away from Cape Canaveral. In addition to the 5th SBIRS satellite, today's flight also includes 2 multi-manifest satellites. Let's take a look at what else we can expect to see.
5, 4, 3, 2. We have RD-180 ignition, and we have liftoff of the United Launch Alliance Atlas V rocket.
The Atlas V RD-180 main engine and 2 solid rocket boosters ignite to generate more than 1.5 million pounds, or nearly 6.7 million newtons of thrust, to lift the rocket on its way towards a geosynchronous transfer orbit. Shortly after liftoff, Atlas begins a pitchover to attain the proper flight path, while minimizing the dynamic pressure the vehicle experiences during flight. The Atlas V reaches Mach 1, the speed of sound, at 47 seconds. Following burnout, the 2 SRBs are jettisoned at 2 minutes 9 seconds to shed their weight. Within the next 2 minutes of first stage flight, the Atlas V rocket will more than triple its velocity. Approaching booster engine cutoff, the Atlas V is burning propellant at a rate of 700 pounds, or 320 kilograms per second.
Like, it's always ridiculous to think about the rockets burn that much fuel.
Having reached space, the Atlas V is now traveling nearly 12,500 miles, or 20,000 kilometers per hour, located 73 miles, or 118 kilometers in altitude, and 235 miles, or 378 kilometers downrange. 6 seconds later, the Atlas Centaur separation system activates to release the booster stage. The vehicle now weighs a little more than 7% of what it did at liftoff. 10 seconds later, Centaur's RL-10C11 main engine ignites for the first burn. Fueled by liquid hydrogen and liquid oxygen, this burn by the newest and higher performing variant of the RL-10 engine powers Centaur to orbital velocity. During ascent, the SBIRS satellite is protected inside a 4-meter diameter payload fairing. At 4 minutes 34 seconds, once the vehicle has climbed above the densest part of Earth's atmosphere, the payload fairing is jettisoned. At 15 minutes 6 seconds, cutoff of the Centaur main engine, or MECO-1, occurs. 31 seconds later, EZ-3 is deployed. EZ-3 and EZ-4 are fully integrated flight systems attached to the aft end of the Centaur. Each of these systems contains a 12U canister containing small multi-manifest satellites sponsored by the United States Air Force Academy that will help in creating critical capabilities that support the warfighter. Following EZ-3 deployment, the Centaur performs a 180-degree roll and deploys EZ-4 at 16 minutes 25 seconds. At 31 minutes 6 seconds, the Centaur main engine is restarted. Following a nearly 3.5-minute burn, powered flight is complete, and the Centaur main engine shuts down. Centaur and the spacecraft will coast for the next 8 minutes. At 42 minutes 46 seconds, Centaur releases the 5th SBIRS GEO Satallite for the United States Space Force, providing early missile warning detection for the United States.
Now, what I'm curious is if they'll cut the live stream just after stage set, because they do that with some of the DoD satellites.
This is the 87th Atlas V launch and ULA's 144th mission. Built in Decatur, Alabama and Harlingen, Texas, Atlas V is comprised of a common core booster powered by an NPO Energomash RD-180 engine, equipped with 2 Aerojet Rocketdyne solid rocket boosters, and a Centaur second stage powered by an Aerojet Rocketdyne RL-10C11 engine, and equipped with a 4-meter diameter payload fairing. Events began with lifting the 107-foot or 33-meter booster onto the mobile launch platform at the vertical integration facility. Then the SRBs were mated to the booster. After the satellite was encapsulated inside the payload fairing on April 30th, it was transported to the vertical integration facility on May 7th, where it was mated to the Atlas V rocket at Complex 41. An Atlas V launch countdown begins with moving the rocket from the VIF to the pad. 6 components are used for the 20-minute, 1/3 mile trip to the pad. The MLP, which weighs about 2 million pounds, supports the rocket and contains air conditioning, electrical, and commodities lines. Undercarriages bear the weight of the MLP and rocket. 2 rail cars lead the move. The payload van provides spacecraft communications. The ground van provides support for the rocket. At the rear of the convoy is an environmental control system providing air conditioning to the payload and rocket. Trackmobiles power the nearly 3 million pound convoy. The Atlas V rocket stands 194 feet, or about 59 meters tall, and weighs just under 1 million pounds, or nearly 431,000 kilograms, fully fueled. ULA's Atlas V is launching the 5th dedicated satellite in the space-based infrared system. Built by Lockheed Martin, this is the first launch of a satellite using the company's modernized LM-2100 combat bus, an enhanced space vehicle that provides even greater resiliency and cyber hardening against growing threats, as well as improved spacecraft power, propulsion, and electronics. SBIRS GEO 5 is equipped with powerful scanning and steering surveillance sensors to protect our nation 24/7. These infrared sensors collect data that allow the U.S. military to detect missile launches, support ballistic missile defense, expand technical intelligence gathering, and bolster situational awareness on the battlefield. Also riding on today's Atlas V are 2 multi-manifest satellite vehicles, EZ-3 and EZ-4, which contain 2 technology demonstration orbiters known as TDO-3 and 4. These satellites, sponsored by the Department of Astronautics at the U.S. Air Force Academy, will ultimately be used to create capabilities that assist the nation's warfighters in performing their critical missions. Led by the Mission Manifest Office, this multi-organizational design, analysis, manufacture, test, and integration effort was performed within just 9 months. Getting a rocket and satellite prepared for launch require a lot of work coming together at the right time. Mission Integration Systems Engineer Tim Pika tells us how it's done.
Primarily, our focus is on defining all of the interface requirements to take.
I love seeing the background stuff of this, just to see how many people actually go into launching a rocket. It's literally thousands of people go into launching a single rocket.
Requirements, and then on the tail end of the mission, right around now, is where we're finishing all of the verifications tied to ensuring that we meet all of the requirements to get both SBIRS and Centaur to end of mission successfully. The work really starts about 2 or sometimes even more years before a launch, where we get a set of requirements from the payload customer, and then from there it's an ongoing process to work with both the payload manufacturer as well as the government teams to kind of make sure all of the requirements are defined for all those interfaces between our rocket and the payload. ULA does have a history of launching SBIRS missions. We've done 4 to date, starting back in 2011. What's unique about SBIRS 5 is that Lockheed Martin redesigned the satellite. Specifically, certain thermally sensitive components are in new locations. In the case of SBIRS 5, we do consider it a short coast mission, meaning it's only about 43 minutes from the time we launch to the time we separate. So it did pose some unique challenges for us to ensure that we could keep all of those components on the satellite within their thermal constraints. With SBIRS, we do have the 2 additional CubeSats that we consider auxiliary payloads to the mission. So our primary goal is to get SBIRS where it needs to be successfully, but we also have in work with the auxiliary payload team, which is a different customer, to define their requirements and make sure we get those payloads where they need to be. One of the challenges with this is you need to make sure that the requirements for the secondary payloads don't induce extra risk onto the primary payload. So that really is the exact same process we go through with the primary payloads, but with the added step of ensuring that nothing we're going to do with the secondary payloads is going to increase risk to successfully completing the SBIRS mission.
Yeah, it definitely looks windy there. Very windy. Some rough waters, but apparently it's within the limits of the Atlas. So as of right now, we're still go.
Mascot for SBIRS is front and center in its claws to represent
That's
the
pretty
missile warning mission.
awesome.
We also see 5 red wings emanating from the center star to represent the SBIRS infrared capability, as well as this, the 5th GEO satellite. Finally, the SBIRS motto, always vigilant, is imprinted on the
That's pretty cool. And they got the Space Force logo above it.
As we continue toward liftoff.
Right
In a few
there.
moments, launch conductor Scott Barney will poll the launch team for the final go to pick up the countdown. 29 engineers and managers are polled for system status and readiness to proceed. This is the final status check for all Atlas vehicle systems, ground systems, spacecraft, and the U.S. Space Force Eastern Marine. The vehicle system readiness poll includes electrical systems, hydraulics, pneumatics, propulsion systems, flight control, and propellants. Let's listen in as Scott Barney performs the final poll.
Wow, people don't have masks on.
Go. Roger, step 150 is now verified.
That's good to see. Good to see.
LDLC, that one.
All right, here we go.
LDL.
Here's the poll.
Yeah, we are close, very close to our topping. Recommend extending the hole.
Mm.
I copy. LC switch will remain in not ready position.
Okay, they're going to extend the hold. So I wonder what the new T0 will be.
Scott Barney recommended to the launch director that we extend our built-in hold for just a few minutes while the team monitors the propellant conditioning issue. So we will stand by and await the updated T0.
Okay. So there is a extended hold. I don't know how long they're going to be holding for, but they are going to be extending. Apparently there is an issue that they are tracking, but it doesn't sound like they're going to scrub it. So we shall wait and see. Shall wait and see. Checking their Twitter right now to see.
LC Lux 1.
Go, Lux 1.
Focus, suppressive charges.
Roger.
Okay.
And Lux 1 LC, your status on step 8.
Alice and Bella 2 at flight level.
Roger. And with that, all steps are complete prior to the stage.
LCSTD.
Go.
Spacecraft is configured for launch.
Boom. There we go.
Roger. And RLM LC. Go ahead. Again, verify red line monitor and event table and correct configuration for the count. Verify. Roger. Okay, all personnel stand by for the stage. And we're gonna do T0.
Cool. Sounds like we're good. That is great news.
With all the required activities prior to terminal count now reported complete, the team will choose a new T0 and moving here momentarily.
1737.
Oh, okay, so they only pushed it back. So 1:37 here in 10 minutes.
RC is coordinated new T0 1737 Zulu.
1737 Zulu in work.
ALC set the clock for a T0 1737 Zulu.
Roger.
Copy.
All right.
LC, ALC.
Go.
Countdown clock has been set for a new T0 of 1737.
Roger.
Oh, -9 minutes.
9 minutes and counting.
LC, RC, at 1. Go RC.
New T0 is approved.
Roger. Okay, all personnel, we have an approved T0 for 1737 Zulu. LC switch to the ready position.
Cool.
All steps are complete prior to the status check.
And as you just heard, the clocks are now set for our new T0 of 1737. The range is approved. in the T0, and the T0 is
1737,
now ready for
which is 1:37 p.m. Eastern Standard Time.
resume his activities and conduct the poll for terminal count in just over 1 minute.
Lots of people on that beach right now waiting for it.
Oh, minus 8 minutes.
Lots. 8 minutes. Eight minutes to go. Less than that. Beautiful day there in Florida, it looks like. I know it's a beautiful day where I'm at. It's sunny and nice, so it looks great down there.
Oh, minus 7 minutes.
Status check to proceed with terminal count.
There we go.
Propulsion.
Go.
Hydraulic.
Go.
Pneumatics.
Go.
LO2.
Go.
Water.
Go.
Centaur systems propulsion.
Go.
Pneumatics.
Go.
LO2.
Go.
LH2.
Go.
Has gas.
Go.
Electrical systems airborne.
Go.
Ground.
Go.
Facility.
Go.
RFFTS.
Go.
Flight control.
Go.
GCQ.
Go.
Operations support.
Go.
COM.
Go.
Umbilicals.
Go.
ECS.
Go.
Red line monitor. Go. Quality.
Go.
Op safety manager.
Go.
ULA safety officer.
Go.
Vehicle system engineer.
Go.
Anomaly chief.
Go.
Range coordinator.
Clear to proceed.
Launch director.
Launch vehicle is ready to launch.
Mission director.
You have permission to launch.
Proceeding with the count. ALC.
Bingo.
T0 is set for 1737 Zulu.
Verified.
Bingo. We going.
Polling is complete. The ULA launch team and the Space
All
Force
right,
mission director
guys.
are go for launch. From T-minus 4 minutes until launch, you'll be listening to Scott Barney and his team performing the final steps in the countdown procedure. You'll
Looks
hear the
like it's
call out
happening.
The Atlas liquid oxygen topping has been secured, followed about a minute later by the call out for transferring the Atlas and Centaur stages from ground facility power to internal battery power. At T-minus 1 minute 55 seconds, the team will command the launch sequencer to start, followed shortly by securing the Centaur liquid hydrogen and liquid oxygen topping activities. At T-minus 1 minute 40 seconds, the team will command the flight control system to launch enable and arm the flight termination system. In the final minute, Atlas tanks will be verified to flight pressures, followed by a verification of Centaur tank pressures. A final status check of Atlas, Centaur, and SBIRS GEO 5 readiness is conducted at T-minus 25 seconds. At T-minus 3 seconds, the RD-180 engine will roar to life. After liftoff, you'll hear the voice of Patrick Moore providing launch vehicle ascent data.
STD, this is LC. Please re-verify spacecraft remains configured for launch.
Verified.
Cool.
All steps are complete prior to terminal count.
Sweet. Looks like it might happen today. But then again, with rocket launches, they can get scrubbed literally at the last possible second. I mean, with this kind of rocket, as long as the solid rocket motors don't ignite, you're good. Once those ignite, you're going. Doesn't matter. You hope up, but you're going.
This is Atlas Mission Control at T-minus 4 minutes and holding. We anticipate releasing the hold in just a few moments.
On my mark, the time will be T-minus 4 minutes and counting.
Here we go.
3, 2, 1, mark.
There we go. There's the hold release.
The countdown
355.
clock has resumed, and we are go for launch at 1:37 p.m. Eastern Time.
Woo! Come on. Alright, seems like we're go. Well, we are go. We are in less than 3 minutes and 20 seconds before this bird lifts off. Those sounds. Rockets, I swear, are alive. Anytime you hear them, they're like breathing. The astronauts that rode on Crew 1 and Crew 2 and Demo 2 for SpaceX all said that Dragon sounded alive. The rocket was like breathing. It's cool. Looks like stage 1 is now pressurized. It's not venting or they're pressurizing it. So calm and quiet, you can hear the birds. That'll all change.
Vehicle internal.
We got some ice chunks breaking off right there.
150.
Securing Centaur LH2.
Securing Centaur LH2.
That doesn't sound good.
140.
Launch enabled.
137.
That was loud, whatever that was.
T-minus 90 seconds. The launch vehicle, payload, ground systems, and eastern range are go for launch.
Cool. Well, they don't see anything, so.
120.
OCUs are.
FCS count started.
110.
Vent valves locked.
T-minus 1 minute.
Oh, here we go.
Range status.
Range green.
All right.
40 seconds.
Stable at step 3.
Here we go.
25.
Status check.
Go Atlas.
Go Centaur.
Go SBIRS.
All right, here we go. Come on.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, Atlas ignition, 2, 1, and
there we go.
Liftoff, the United Launch Alliance Atlas V rocket with the 5th space-based infrared system satellite for the United States Space Force.
Now 15 seconds into flight. PU's gone to closed loop control. Engine operating parameters continue to look good.
You are hearing the voice of Patrick Moore providing launch vehicle ascent data.
Vehicle's now completing the pitch over program. Body rates look good. Seeing good chamber pressure on both SRBs. And RD-180 now beginning the throttle bucket. Engine response looks good. And now passing through.
Oh, look at that.
5 is now supersonic and max Q, maximum dynamic pressure. Body rates continue to look good through the boost phase. Vehicle's now throttling back up slightly. Engine response continues to look good. Chamber pressure on both SRBs continue to look good.
Beautiful.
Now passing
Beautiful.
1 minute, 10 seconds into flight. Atlas is now 10 miles in altitude, 4.5 miles downrange distance, traveling at 2,000 miles per hour. 1 minute, 20 seconds into flight, standing by for SRB burnout shortly. Body rates continue to look good. Chamber pressure on the SRB is now tailing off. And we have burnout on both SRBs. Atlas will hold on to the SRBs for an additional 39 seconds before jettison.
Oh, it's going to hold on to
Throttle
them.
back up to full thrust. Engine response looks good.
Interesting.
Now passing 1 minute, 50 seconds into flight. Body rates continue to look good throughout the boost phase. And the Atlas V now weighs 1/2 of its liftoff weight.
Jeez. It's always insane to think about how much fuel that they
And
burn.
standing by for SRB jettison shortly.
There they go.
And we have good indication of separation of both SRBs. Now just under 2 minutes remaining in the booster phase of flight. Vehicle's gone to closed loop steering, seeing a slight correction in the body rates, now damping out nicely. Body 180 engine operating parameters continue to look good. RD 180 throttling down slightly now as expected. Two minutes, 40 seconds into flight. Atlas is now 39 miles in altitude, 68 miles downrange distance, traveling at 5,400 miles per hour.
You can see the plume from
And
the
reaction control
SRBs
systems
right
now
there.
Pressurizing the flight levels. System response looks good. Now coming up on 3 minutes into flight. RD 180 pump speeds and injector pressures continue to look good. Body rates continue to look good. Now about 1 minute remaining until booster engine cutoff.
Cool.
Pump speeds and injector pressures on the RD 180 continue to look good throughout the boost phase.
Now, what's going to be really weird is once it separates, it's going to ignite the Centaur engine, or the Centaur upper stage engine, and it's so weird. It doesn't look like it actually starts, but it does.
Downrange distance, traveling at 9,000 miles per hour. And RD 180 is now throttling to maintain a constant 5G acceleration limit. RD 180 responses look good.
Perfect. Perfect.
And Centaur's begun the boost phase chill down sequence. RD 180 now going to 4.6G throttle limiting, standing by for PICO. And we have PICO booster engine cutoff, standing by for stage set. And we have good indication of stage separation. We have pre-start on the RL-10, standing by for ignition.
Now see,
Ignition and full thrust on the RL-10.
it ignited, but it does not look like
Body
it.
rates look good.
Like, it is on and
And we have good
throttling up.
indication of payload fairing jettison.
That was cool. You can see the shadows.
First burn of today's mission will
Wonder
last
if we'll see 'em.
approximately
Yep,
10
there's
minutes,
one.
30 seconds. RL-10 engine operating parameters look good. Body rates have damped out nicely from the startup transients.
Cool.
And the RCS system has begun the initial thruster firings for system thermal conditioning. Just over 5 minutes now remaining in, or 5 minutes now into flight.
That's wobbling a lot.
RL-10 chamber pressure looks good.
I've never seen that before.
This is Atlas Missions Control at T plus 5 minutes, 20 seconds. Patrick Moore just confirmed successful completion of the early phase of today's flight, and all systems continue to operate nominally. The mission is currently in the first Centaur engine burn. Our next event, Centaur main engine cutoff, will occur in approximately 10 minutes. Lockheed Martin builds the SBIRS satellites for the U.S. Space Force. Here's a video highlighting the power of these satellites.
That doesn't look right, but I could be wrong. That didn't look right. I could be, again, completely wrong. I'm not an expert on this stuff, but That didn't look right. It was almost like it was sideways.
Seconds into flight.
Oh, these guys don't look worried, so.
Last week, I had the opportunity to talk with Lockheed Martin's Melanie Young about the incredible capabilities SBIRS 5 brings to the constellation. Let's take a look at our conversation. Hey, Melanie. Thanks for joining me this afternoon. Can you tell me more about what you do for the SBIRS program?
Yeah, thanks. I'm really excited to be here. I am a systems engineer for Lockheed Martin Space, and
All right. So just kind of waiting here for a second. I'm gonna wait for main engine cutoff on the Centaur booster, and then I'm gonna get out of here. But thanks for joining me. I really do appreciate it. It's a little bit weird. I think it was a camera angle. Now that I'm thinking about it, how it was doing it, it was rotating, but it was the camera angle. It didn't look correct, but. Yeah, it was a good launch. Successful launch. What is the next launch is a good question. Looks like May 26th. It's a Falcon 9. At, about 3 p.m. Cool. Alright, folks. Well, yeah, like I said, I'm kind of waiting just till main engine cut off. I do have to get out of here. As soon as that happens, I'm out. But thanks for joining. I do appreciate it. It was fun. It was a good launch. I was kind of hoping they would be posting something about it. This stuff, I feel like, should have been done before the launch ever happens. Because I'm going to be real, once the rocket launches, we all just want to see the launch happen. I get that this stuff is important. And it probably takes up time because no one just wants to see an animation of a booster or part of a rocket continue on. But I do. I don't know how everybody else is. But it probably just, it's to buy time and stuff. Because it is just accelerating. Sad. All right. Well, it's not May 17th, but All right. I do not see.
The Atlas, Centaur second stage, and SBIRS GEO 5 satellite are currently located over the Atlantic Ocean, west of Africa. Our next event, the first Centaur main engine cutoff for MECO 1, is coming up in a few minutes, followed by deployment of EZ3 and EZ4. Once again, here's Patrick Moore.
It was as expected, and telemetry quality continues to look good.
Cool. Well, it looks like they're going to do it. I got to get out of here, but thanks for joining me. I do appreciate it.
Coming up on 12 minutes into flight.
Take care, guys. It was a great launch, but I will see you all later. Peace out, guys.